Hi everybody, this is an examples video on separable differential equations, and in this video we're only going to find the general solution. So here are the three problems that I'm going to go through in this video. If there's a specific one that you're looking for, you could of course just forward to that point, or you could always use this as a way to kind of quiz yourself. Okay, so let's get started. So starting with dy dx equals 2x times the square root of y. So for a separable differential equation, basically you're putting the stuff that has, so the dy's and the y's, these are what's kind of separable. These are going to go together, and then these parts are going to go together. So if you think about it then, you're going to really, let's see, maybe I'll just kind of show you all the steps over here kind of off on the side just to make this nice and pronounced. So what you're going to do is you're going to divide this side by the square root of y, and then on this other side, so you're going to multiply both sides by dx. No, it's not looking quite right. So here's kind of the work that's going on. So when you do that, here's what you're left with. So on this side, I've got 1 over the square root of y dy, and then on this side, I get 2x dx. And so you actually are going to now integrate each one of these sides. Now, if you're looking for a deeper explanation on why this works, I do have an entire lesson video where I actually break this down. So in example videos, I usually just plow through the example. So if I now just go ahead and integrate each side, so I usually like to write, I like to write the expression without the square root sign. So then to finish this, this will be 2y to the 1/2, and then this will be x squared plus c. So the c, you just traditionally put it on the x side, and that's it. And since we're just looking for general solutions, that means that this is as far as we can go with this one. Okay, so moving on to this next one. So if you look at this, at the moment this does not look separable. So the thing that makes something separable is that you can really easily separate the x's and the y's kind of via multiplication. But what you can do is you can kind of distribute this exponent in. So I can rewrite this as dy dx equals x to the 3/2 y to the 3/2, and now you can see that this is definitely separable. So these are going to go together, and then the x's are going to go together, and we're going to integrate. So the way that this will look then, this will be 1 over y to the 3/2 dy, and then on the other side this will be x to the 3/2 dx. So remember, you're dividing both sides by the y, so that's why this ends up turning into this fractional piece. Okay, so now if I actually go ahead and I do my integration, this will give me -2y to the -1/2. I like putting everything just in its exponential form, and then this will be 2/5 x to the 5/2 again plus c. So that's as far as you can go with that one. Okay, so now for this last one. So this might look slightly more confusing, so you have to like kind of pause for a second and really take a look at this. So when you take a good hard look at this, so here are where my y's are. So I've got my dy, I've got a y here, and then this little expression here also has my y's. So this is actually separable, right? I can break this up by multiplication, and then for my x's, so I've got my dx, and then I've got these pieces. So if I want to just make it really explicit kind of how we're going to separate all of this, so this side is still going to be my dy dx, but this side will be, so this will, I can separate this as x to the 5th minus 1 over x squared, and then y cubed over 3y squared minus 2. So here's how this really separates. So then you're really multiplying by the reciprocal of this to bring this over to the other side. So the way that this will look then is 3y squared minus 2 over y to the 3rd dy, and then on this side this is x to the 5th minus 1 over x squared dx. Okay, and so now that I have this all broken up, I can actually simplify this a lot, right? So I can turn these into fractions and make this much simpler. So let me clear myself a little space. And now we can simplify the fractions. So this will be 3 over y minus 2 over y to the 3rd. So here's the first part I need to integrate. And then on this side, this will be x cubed minus 1 over x squared. And so here's what I need to integrate on this side. So now when I integrate, so be careful with this first one, right? So when you just have anything over y, or just the singular negative y to the -1. So when you integrate this, what I'm trying to say is this will be the natural log of the absolute value of y minus, well, this will come out to 2 times -1/2 y to the -2nd. And then this will be 1/4 x to the 4th. And then this will become minus negative, let's call this x to the -1st plus c, which if I simplify all of this, so maybe let me just clear, let's see, I think I can write this up. Let me just move everything. Okay, now I have some space, so this will be 3 times the natural log of the absolute value of y plus y to the -2nd equals 1/4 x to the 4th plus x to the -1st plus c, or you could write those in their fractional form, whatever works for you, but that would be the final answer. And so that covers it for this video. So those are the 3 examples I have. So I do have, like I said, a entire lesson of just explaining how this technique works, and I do also have an example video on initial value problems, so feel free to check both of those out if you're looking for more explanations. Thanks for watching.